Okay, so ciao everyone. My name is Mattia, and today I'm going to talk to you about basically what it means to talk about web performances. So it's going all to start with a pretty simple question, which I usually ask during interviews, which is, what exactly happens when you write a web address in your browser and you press enter? So you want to go on Facebook or on the website you work for. And what exactly happens in terms of performances? Of course, a lot of things happen, but what we care about today is basically something like this. So when I was young, what happened was something like this. The browser basically sends an HTTP request to the server, requesting a page, and the server comes back with some HTML code. And that was pretty easy. So basically what we needed to measure at this point was the time it took for the HTML to be rendered, to be sent back to the browser. So we needed to measure how long it took for the server to send the HTTP response. And that was pretty easy. It was pretty cool. Thing is, it worked until web pages were like this. And that's okay. I mean, at this point, it's pretty easy to measure performances on the web. You just look at the access logs on your web server, you know how much it takes for the HTTP response to get back to the browser, and you're done. And that's okay. But at some point, this guy comes up. He's called Vincenzo. He's the UX designer in my team. Probably all of your teams have their own Vincenzos. And what they do is basically they ask for complex user interfaces. So they want more stuff, a lot of stuff on your page, sound, videos, special effects, custom fonts, whatever. This means that when the browser asks for a web page, okay, the same thing as before happens. The server sends an HTTP response with some HTML, but the page is asking for some separate assets. So CSS files, images, JavaScript files for interactions, custom fonts, and whatever makes our Vincenzos happy. Okay, so this means that the browser is going to have to do more HTTP requests. So we're no longer able to keep track of the single server response time, and we need to measure performance in a different way. So we need to measure how much it takes for the document to be complete, how much it takes for the load event to be performed, how many requests are we actually making. The idea is that we should at least try and keep this number of requests and the amount of stuff that we're having the browser download as low as possible. But Vincenzos tend to win. So basically what happened is that the size of the amount of content that browsers have to download keeps increasing. So basically what happened is that up to a couple of years ago, so this is May 2015, this was the average size of a web page. It's 2 megabytes. So I'm quite old, and I have an idea of how much is 2 megabytes. How much do you think is 2 megabytes? Basically, to give you an example, 2 megabytes is this. So this was 2 megabytes, and this is the average web page size 2 years ago. That's so cool, until this guy comes up. So you may say, okay, I'm on a DSL connection, I have a fast Mac, I have the latest Chrome, it's all cool. Why should I care if I have my users download 2 megabytes of stuff? I don't care, they have fast connections. That's true, but in 2006, this guy, which you may know, comes up with a study and says that for every second it takes longer to download for web pages, they lose $1.6 billion. So basically, what it's saying is that the faster you make your web applications, the more money you make, which is generally a good thing. Panic. We need to make our web pages faster. What do we do now? A lot of stuff. So this is basically all that happened in the performance optimization scene in the latest years. So these are basically best practice that you probably already know. So you tend to minify your JavaScript and CSS file. You tend to cache everything you can. You tend to combine images in a CSS sprite to reduce the number of HTTP requests. You lazy load stuff. You use CDN to try and make HTTP requests in parallel. You move the script tags at the end of the body. Or in the end, you could just decide not to care about performances and target just a single browser, and yeah, that's it, I'm done. It's a choice. Then something else comes up. So up to now, we were just talking about web pages. But as you probably know, talking about web pages in 2017 doesn't make any sense anymore. Because today, what we work on is actually web applications, no longer web pages. So when Gmail comes out, this was probably one of the first versions of Gmail, but it's really not a web page. It's an application. It's something that you download in your browser where you do stuff. So basically what happens is that your browser sends a request to the server and tells him, hey, can I please get the Gmail application? So it's no longer a page, it's an application, which means that you still have to download a lot of separate assets. But the user interaction, once the page is downloaded, is not complete. You're going to do stuff after the page is complete, which may or may not involve some server requests. So again, the metrics that we use to track performances are no longer relevant, and we need to find some new ones. So Google introduced the speed index some years ago. But for instance, you could also consider as relevant the time to the first meaningful paint, meaning that you need to track the time it takes for the users to see relevant content, which means that the skeleton of the page has been downloaded, probably most of the JavaScript code has been run already, and you're actually showing relevant content, which is tricky because you need to determine what is actually relevant for your application. You may also want to try and track how much it takes for your application to be interactive, because, for instance, you need to initialize a whole bunch of JavaScript code, which will take some time, and you may want to track that. So it's a new metric that you have to track. Once your application is loaded, and users are using it, and hopefully making profit, you may also want to track frames per second. So it's no longer a page that it gets downloaded and it's done. It's something that's been used, and how much is going to be used depends on how well it's performing once it's loaded and once users start to actually do things with it. Which means that at this point, how much it takes for the page to load starts not to be that relevant as well. I mean, the HTML gets downloaded, okay, do I care? Not really, because it's really the least part of the time it takes for my application to show up. So basically, a small percentage of the time is spent by the server to send back the HTML, but most of the time is spent rendering the HTML, executing JavaScript code, probably doing some Ajax stuff, and so on. So at this point, since we work on web application and not any longer on web pages, we want to track and to optimize the performance that will actually happen in the browser and no longer on the server. So again, new techniques are required for these new metrics that are required. So for instance, you could try using server push, which is pretty new, not really, but it's getting common, but it's pretty new because it's something related to HTTP2. And you could try inlining the critical part of the CSS. I will show you something more about this later. You could try splitting your page and caching fragments of your page. It's a pretty cool technique. It's called edge-side inclusion. So basically, what happens is that you have a proxy in front of your application that caches fragments of your page so that you no longer have to go all the way to the application server. It's pretty cool. But one of the most interesting things that you can do is using new and more advanced compression algorithms. So again, Google which is pretty at the forefront of the optimization techniques front, has introduced some new compression algorithms. Say, for instance, one is called Brotli. I don't know if you know it. And it's pretty interesting because it's really optimized for the HTTP streaming part. And yeah, that's probably one of the things that you can do now to increase the performances of your web application. So going more in detail about these techniques, server push is pretty cool. The fun stuff about server push is that it's extremely easy to implement. So it basically requires you to add a single HTTP header in your responses. And basically what it does is that when your browser downloads a web application, it no longer has to wait for the HTTP response, for the HTML of the page to get back to the browser, but it can start downloading a lot of assets in parallel, which in turn resolves to less time to show stuff. So basically, this was what happened back in the days. So you got the HTML for the page. Inside the HTML, you had the style tag requesting to download the CSS file, a script tag requesting to download the JS file, and an image file in another tag in the HTML. What happens with HTTP2 is that the asset requests can be run in parallel. And this is already pretty cool. But if you implement server push, so basically you add a link header in your HTTP response suggesting that the browser should download style CSS, a JavaScript file, and an image in parallel, they all get downloaded basically as soon as the HTTP response gets back to the browser. So it no longer has to do the HTML parsing to start downloading the assets. It gives, as you can see, an interesting advantage. The drawback on this is that you may start facing some caching issues in case these assets tend to change pretty frequently. But in general, I would say this is a good rule of thumb. It's really a low-hanging fruit. So Salvatore earlier mentioned low-hanging fruits. This is really a one-liner in terms of code, and you can see the benefit it gives in terms of performances. So no reason not to use it. The critical CSS part is really one of the most recent techniques. I mean, I would say it's recent, but as you can see, it's not really that recent. It's a couple of years old. So basically, it's been first thought of by the guys at Smashing. And basically what it means is that there are some parts of your CSS code that are relevant for like the first meaningful paint, so for what you see above the fold. And those are the parts of your CSS code that you want to download as soon as possible. So in this case, this technique requires you to actually have it in line. So you don't download a separate file, but it's actually part of the HTML that the browser downloads for the first request. It's a little counterintuitive because, as I told you, I'm pretty old. I was always told that inline styles suck. Turns out they don't. Because inlining the critical part of your CSS allows you to show your most relevant content without having to perform a separate request. And then what you do is that you download the non-critical part of your CSS asynchronously, possibly through JavaScript. Okay, this is pretty cool. It gives good advantages in terms of rendering time. There's an issue with this. So how do I determine my critical content? How do I determine which parts of my CSS are actually critical and which parts are not? Turns out there's a tool for that. So the always good Addi Osmani, which is one of my favorite guys, has actually built a tool. This is actually recent. It's been released like last week or so. And basically what it does is that I think it's an NPM script or something like that. Anyway, it runs in Node. And what it does is that it starts up a headless Chrome, which loads your web pages, and it's able to automatically determine which parts of your CSS are critical and which are not. Sounds extremely useful to me. So, okay, we now have, luckily, most of the browsers have good enough dev tools to help us determine which parts of our application stack we need to intervene on to actually optimize performances. So we have no excuse not to do some optimizations because we're able to determine exactly which parts of our code are the bottlenecks, which parts are going to have the most impact when we optimize. That's cool. Until this guy comes up. This guy comes up and says, okay, you're used to work in a browser with your super cool dev tools, with your DSL connections. Okay, not anymore. Because now we have a lot of viewports, possibly extremely small, and a lot of different connections. So this is pretty fun from a developer point of view because now we have a whole set of different challenges to work on. But what it really means in terms of measuring and optimizing for performances is that the answer to how fast does my web application go now is always, it depends. So we're no longer able to say, my web application is fast, my web application is slow. It depends. And the only thing we can do now is to actually try and track how our web application perform on the user's devices. We're probably no longer able to test on every possible device. So we could use our users to do the measurement for us. We can no longer say something like this. My website loads in 7 seconds. Where? How? On what devices? On what conditions? This sentence is totally no longer relevant. Which means that we need to do something new. So this is actually the state of the art of performance measurement. So, as I told you, what we need to do now is to track how our web applications are actually performing on the user's devices. So, saying that my web application runs cool on my Mac doesn't make any sense anymore. I need to know how it works on the user's devices. So, for instance, I can use the browser navigation timing API, which is pretty new, but it's well supported in browsers. And it basically allows me to know how much it takes for every part of my page rendering process. So say, for instance, I can keep track of the time it takes for the response to start downloading on the browser. I can keep track of the time it takes for the DOM to become interactive. So probably some of the most relevant events in here are these. So basically, I can keep track of these. Say, for instance, Google Analytics does this as well. And you can keep track of how long it takes for your users to actually do the whole rendering process. And you have a good segmentation on this. This is super important because it allows you to actually determine and notice potential bottlenecks on the actual user's devices, which is what you really should care about. You could also keep track of application-specific events. So these are events that happens for every web page, for every HTTP request, for every web application. But, of course, we mentioned that your web applications are going to be pretty complex, and, of course, they should be at least unique and do something that no other applications do. So with the Performance API, what you can do is basically keep track of events that are specific to your application. Say, in this case, this is the event in my application when the advertising part basically starts doing its own thing. And I want to keep track of this because this is the time when my application code has finished executing and the advertising code starts doing whatever it does. So at this point, I know my part is done. And I want to keep track of this, and it's not part of the standard HTTP or HTML events. Cool thing about this is that Google Analytics, for instance, keeps track of these as well. So you could use the Google Analytics segmentation, for instance, to say, okay, how much does it take for this event to be triggered on iPhone 5s of people using 2G connections? So again, you're able now to keep track of your user base, determine which user segment is actually relevant for us, and measure performances specifically for the user segment that you care about, specifically for the application parts that you care about. And that's pretty cool. So this is actually something I've never seen in production yet, but the Google guys, again, they seem to be pushing pretty hard on this. It's really not a single technique. It's more of an architectural pattern for developing applications. I think it works pretty well on Angular applications, of course, being this a Google technique. So basically what it means is that you do HTTP push for the critical resources for basically what once used to be called your landing page. So you do HTTP push for that. You have all the assets and only the assets you need for your initial route. You render that, and then in background, you start pre-caching stuff and lazy loading stuff for the other routes. So basically, you can think of this as inlining the critical CSS on steroids, because you do pushing for all the assets you need up front, and you do all the rest in the background. This is basically what it means. The cool thing about this is that probably the step forward, even forward after this, is trying and doing some kind of client-side prediction on which the remaining routes may be. So this is actually pretty vague. Remaining routes, okay, I rendered my first route, and then at some point I will lazy load the others. Okay, I may have a hint on what the next route will be. Say, for instance, think of a login funnel. It's done in steps, so you could do a good guessing on what the next route could be. So, basically, to wrap up, performances matter. Jeff Bezos told us, we know performances equal money. That's pretty easy. Thing is, we're no longer working on web pages. It's getting hard, which means that we need to do complex things to make our web applications go fast, which means that we can have fun as developers. The hard thing, actually, today is that you need to identify what it really means for your applications to be fast. So load time is no longer relevant. Define what's relevant to your applications. And, of course, you can even start talking about performances without measuring. You need to measure everything. You need to keep track of everything before you even start thinking of optimizing stuff. That's pretty cool. We're done. My application is super fast, and it works super cool. My users are happy. I'm getting rich. Not really. As you may have seen earlier, the application code you write is likely not to be the only application code that is getting executed in your browsers. So for instance, this is some data from my web application. So the backend takes super little time, then the page starts getting rendered, and then what happens between here and here? Nobody knows. So this is 4 seconds. The page has actually started rendering, and something has been rendered. So it's probably not the first meaningful paint, but something close to that. 8 seconds. Still some relevant content. A lot of time later, what's the difference between this and this? It's advertising. So advertising takes a lot to render. And the bad thing about that is that you can do nothing about it because it's not your own code. So, okay, we still need to measure all the things and determine the metrics that are important to us. But at some point, we may end up in a situation where we can optimize our applications as much as we can, and still the websites are slow. Still our applications are slow. Okay, what do we do then? We just need to communicate. That becomes a communication issue between you and the rest of your team. And you have to be able and to be good in communicating that, okay, I did as much as I could, but now it's on someone else's table. Of course, at this point, optimizing your own application code may not be relevant anymore because it's not the actual bottleneck. So again, you should be optimizing when it really makes sense and not when it doesn't. So basically, the thought I want to leave you is this guy. How many of you know who this guy is? Okay, that makes me feel old. So this guy is called Donald Knuth. He's one of the old school gurus in computer programming. He wrote a series of books called The Art of Computer Programming, and they basically cover everything you can think of when writing code. So one of the quotes he's most famous for says that premature optimization is the root of all evil. So basically, what it means that you should never start optimizing code just because it makes sense. Again, Salvatore mentioned it earlier. Micro-optimizations and optimizations that somehow ruin your code don't really make sense. So the thought I want to leave you with is that when you want to optimize the performances of your applications, first of all, you need to measure how it performs and to identify if it would make sense to optimize something and where optimizing stuff would actually make sense. So, again, don't optimize things just because it's fun. Because it's fun. Thanks.